So when we look at utility, the concept which is utility which matter to us is basically the concept of total utility. Another concept that matters to us is the marginal utility. Okay, so let's start with the first idea, which is basically total utility. Whenever a consumer consumes a good, any good, he gets some satisfaction. That satisfaction is basically what we call utility. So for us, utility is simply the satisfaction that we get from consuming any good. So let's say if you decide to consume a bar of chocolate, you get some kind of satisfaction. That is the utility that you get. So, and what we say is this, that as we consume more and more of a good, so as quantity increases, the total utility or total satisfaction, TU for total utility or total satisfaction should go up. Make sense? So we believe that when you consume more of a good, your total satisfaction should go up. But we also believe this, that the rate at which it goes up, let me write this here, the rate at which it rises is decreasing. In other words, TU rises at a slower rate. Why does it happen? Let's talk about it in 1 minute. But what do we really mean by this? So we draw a graph of this. We have a quantity on my sort of x-axis, and I have total utility or total satisfaction on my y-axis, right? What we say is this, that as we consume more and more of a good, TU would actually rise, but it rises slowly, right? And we say this, that why do we have TU rising slowly, or how do we know TU is rising slowly? Because look at this, every time TU is rising, it rises at a slower rate. Let's say for the first unit, I get plus 10. For the second unit, my total goes to, let's say, overall goes to, let's say, 18. The third unit pay, my total goes to, for example, 22. So if I ask you guys, what's the change that is happening? The change is actually, for the first unit, it was plus 10. For the next unit, it was plus 8. For the third unit, I'm getting plus 4. The reason why we believe that this is happening is because when we look at total utility, we say this, that the rate at which TU changes is called marginal utility, your extra utility that you get when you consume a good. So marginal utility, or MU, is simply change in TU, extra utility over extra quantity. In other words, we say this, that the marginal utility is the extra utility from an additional unit. So from an additional unit, how much extra satisfaction that we could get, that is your extra utility. Now if you look at this, if I ask you guys, find me the slope for this graph, your answer would be, the slope for this graph would be change in y. So slope would be change in y over change in x, right? That's the formula for the slope, which will actually be, if you look at the change in y is change in TU, change in x is change in quantity, which is exactly what you see here. MU is simply the slope of TU. So why is the slope diminishing? In other words, why is the slope like this? If I sort of want to draw the diagram for the slope or MU, I'm going to draw a diagram like this. This is quantity and MU. So my MU is, for example, first it was plus 10, then it was plus 8. So the first unit, it's like the value is plus 10. For the second unit, the value is, for example, plus 8. And the third unit, the value is, for example, plus 4. So my MU actually looks like this. My MU is declining as my quantity is increasing. So, MU falls as Q rises, but we just saw this, TU rises at a slower rate as quantity increases. And why does this happen? And let's talk about this. But is there any question before we move on? The reason why this satisfaction is going down is because what we say is this law of diminishing marginal utility. This law is like not a physical law, it's an economic law that we actually create. We say this, that as quantity increases, your extra utility or marginal utility falls from each successive unit. So the first pizza slice will give you the most satisfaction, the second will give you lesser than the first one, the third will give you lesser than the second one, and so on and so forth. Every single unit will give you less satisfaction, and that's basically what your law of diminishing marginal utility. And that is why your MU is falling, your MU is diminishing because of this, and TU is rising because each time you get some extra satisfaction, some positive satisfaction, but that satisfaction is lesser than the one that you get earlier. Saying here is just that every time you consume something, your total satisfaction goes up, but at a slower rate, because the extra that you're getting is diminishing. And that's what your law of diminishing marginal utility says that consumer will get a lower satisfaction. Now, why is this important? Because this concept actually helps us in what we call making a demand curve for a good. When you look at this concept, if I look at this concept, basically marginal utility is simply the satisfaction or rather, let me write this, extra satisfaction or marginal benefit of a good. Isn't that true? Marginal utility is simply extra satisfaction or marginal benefit of a good, while the price of the good is the extra cost, also called the marginal cost of consuming a good. So when you buy a good, you pay a price for it. Isn't that true? So what we say is that as long as price is greater than or equal to marginal utility, as long as marginal utility is greater than or equal to price, we will keep on buying a good. Which means that as long as the benefit you get from the good is greater than the price, you will buy the good. What do we mean by this? Let me say this. What if I tell you the price of the good is let's say $8 and the MU is for example worth $6, you will never buy a good. Why? Because the price is more, the cost of the good is more than the satisfaction you get from the good. But if your satisfaction is more than or equal to that good, you will still buy the good. So what a consumer does is that a consumer who's maximizing his benefit or utility or satisfaction will actually look at the marginal utility. As long as the marginal utility is more than or equal to price, he will be consuming that good. Make sense? So for us, MU actually is the value that you will want to pay. So let me write this, that MU is the value a consumer places on the good. It's the price, it's the lowest price that you will pay for the good. If your MU is greater than or equal to price, you will buy that good. Make sense? So that's your concept of the marginal utility and price. I want to now talk about one more thing which is an important concept. The next thing that I want to talk about is basically let's say you are a consumer who's thinking about buying two goods. Like you have two goods. So let's write this two goods analysis. And this is where we're talking about the Equi marginal principle. Okay, so what if I tell you this, that the two goods, let's say apples, A for apples, so let me write this apples are this, and oranges. Okay, and you're thinking about buying these two goods, and let's say the marginal utility that you get from an apple is, for example, a unit of an apple is, for example, 50. Some utility units, some imaginary, let's say you get 50 units of satisfaction. Versus from oranges, you get, for example, 40. And the price is, for example, for apples, let's say, is $10. Okay, and the price from oranges is, for example, also, for example, $10. Okay, now you can see this, that I'm going to ask you this, that okay, if you're spending $10 on apples and you get a satisfaction of 50 versus $10 on oranges, you get a utility of 40. One thing we need to look at, how much are you getting per unit? In other words, in fact, how much are you getting per dollar? What's your per dollar utility from apple versus what's your per dollar utility from oranges? In other words, what you need to find out is what is your marginal utility per dollar spent. So this is what we call MU per dollar spent. In order to find out whether you should buy apples or oranges or both, you got to look at MU per dollar spent. And MU per dollar spent, for example, for apples would be 50 over 10, which is equal to 5. But for oranges is going to be 40 over 10, which is equal to 4. Right? Does that make sense? So what I can say is this, that for you, every time you spend $1 on apples, you get 5 units of utility. But the same amount, $1 spent on oranges, you get 4 units of utility. Which one should you buy? Apples, because the marginal utility, that's an important example to understand, MU of A over price of A is greater than MU of O over price of O. Are you all with me? Can I say this? If MU of A over price of A is greater than, one should argue this, that we should buy more apples and less oranges. Do you all agree? When you buy more apples, basically, so let me write this, quantity of apples should go up, QA goes up, and QO will go down. So you have a budget, you start to buy more of apples and you start to buy less of oranges. The problem that would happen now is that we know this according to the marginal utility theory, something like this. We know this, that if you buy more of a good, let's say from 5 units of apples to like 6 units of apples, your TU may go up, let's say from one value to another, from TU1 to TU2. But at the same time, when you buy more of, apples, the problem is that the MU will start to fall. This is my MU. MU of 1 versus MU of 2. MU would start to fall whenever you buy more of a good. Isn't that true? If you buy more of a good, MU would fall because of the law of diminishing marginal utility. So while you're buying more of apples, quantity of apples is going up, MU of apples is going down. At the same time, MU of oranges, because you're buying less of them, should go up because of what we call law of diminishing marginal utility. this is an important result. Why is this an important result? Because suddenly this part of my equation is going down. I'm buying more of apples. This part of my equation is going down because mu of A is going down. But this part is going up. And right now they were unequal. The left hand side was more than the right hand side. This side was bigger than the, but now when you buy more of apples for oranges, this is start to fall, this is starting to rise. Right? There will come a point. So a consumer will keep on buying more of apples and less of oranges till MUOA over price of A is equal to MU of O over price of O. We believe that you will keep on buying more of apples and less of oranges until this equation is met. And when this equation is met, we say this is called the Equi marginal principle, where the consumer, we believe this, that the consumer has maximized his utility from a given budget. So your total utility is maximized from a given budget, because you can't really buy more of apples anymore or buy less of oranges, because you spend $1 on apple, it will give you the same utility. You spend $1 on oranges, it will give you the same utility, which means there is no advantage of buying more of apples or less of apples, or more of oranges or less of oranges. This is where you have maximized your utility. So in order for a consumer to maximize utility, we believe that marginal utility, let me write this here, we believe that the marginal utility MU per dollar spent must be same. That is, the consumer has sort of met the Equi marginal principle. So must be same for all goods. And this is an important result, because this can actually help us derive a demand curve. And I'm going to show you how it will help us derive a demand curve, and then we'll discuss an essay question on that. But this is an important result, because we can then derive a demand curve from this. So let's write derivation of a demand curve. So how do we derive a demand curve out of this? What we say is simply this idea, that what if MUA over price of A is equal to MU of B over price of B? Or rather, yeah, I wrote B, should be O, right? O for oranges, but let's say bananas and apples. Okay, let's say MU of A over price of A is equal to MU of B over price of B. Okay, do I need to substitute or buy anything more of one thing or the other? No, because my utility is satisfied. Suddenly I tell you guys that price of apple has gone down to PA dash. If that is the case, what will happen to my equation above? Can I say this MU of A over price of A dash is now, because when the price goes down, the denominator becomes smaller, this side will become bigger. First they were equal, now the price has gone down and it's become PA dash. This will be greater than MUB over price of B. Isn't that true? The marginal utility per dollar spent for apples suddenly go up because the price per dollar price has gone down. That the marginal utility per dollar spent for apples is more than marginal utility per dollar spent for bananas, for example. You will buy more of apples and less of bananas, for example. In this example, we have bananas and not oranges. Suddenly I changed the fruit, so don't get upset. You buy more of apples, and what happens as a result of that? MU of A would start to fall. mu of B would start to rise because of the law of diminishing marginal utility. But we keep on buying more of apples and less of bananas until Q mu of A or price of A dash becomes equal to mu of B over price of B. So till we come to this equi-marginal principle, I'm buying more of A and less of B. How do we make a demand curve out of this? Look at this. This is an important thing to understand, that if this is my demand curve for apples, so this is my quantity and my price. So when your price was PA, you were buying certain quantity QA. Then what happened? That when the price goes to PA dash, you bought more of apples. So you bought, let's say, QA dash. Isn't that true? Price went to PA dash, price went down, you bought more of the thing. And if I join these points together, I get myself a demand curve. Demand curve says this: when the price goes down, basically, this is what an important thing to understand. Price goes down.
Demand curve also be called marginal utility.
So what are we saying here is that when the price goes down, the marginal utility per dollar spent goes up, and that's why the quantity demanded will go up. And that's why our demand curve is downward sloping. Like price goes down, the marginal utility per dollar spent goes up, consumer will buy more of this good. But if I ask you guys, what happens to the demand for bananas? Because you are buying less of bananas. Isn't that true? You're buying less of bananas because its MU is going up, but you're buying less of bananas because other goods become cheaper. For bananas, is it a price factor or a non-price factor? It's a non-price factor because it's a substitute, which is apples are becoming cheaper. So for bananas, the reason why you're buying less of it is because for the same price, unki price to change नहीं हुई थी, the price didn't change for that. For the same price, basically, we are buying less of the good. So for bananas, it's a fall in the basically demand, while for apples, it's a movement along the demand curve, and that basically is why the utility theory is important in terms of us telling us why the demand curve is downward sloping. Make sense? Are we good? This is a question which is actually testing our knowledge about the things that we just learned, that explain the link between a consumer's expenditure and the equi-marginal principle, marginal principle of utility. So here, if I could make an outline for this, what we'll first talk about is that what is the consumer's goal? The consumer's goal is basically to maximize utility from his given budget. That's his goal. He wants to maximize utility from his given budget. How does he achieve that? He achieves that through the equi-marginal principle, which is mu per dollar spent of good A or price of good A. Mu over price of good A should be equal to mu of B over price of B. Okay, so that would be basically what we need to write. Then we talk about basically that your mu and tu, the distinction between that. Tu is simply defined as the total satisfaction that you get from consumption of a particular quantity, and mu is the extra satisfaction that you get from one extra unit. Isn't that true? So you talk about mu and tu. You will draw the diagram for tu. That tu rises as Q increases, but at a diminishing rate because of the law of diminishing marginal utility. And then you'll draw your graph for mu, which is like this. Okay, either आप लिखेंगे mu and q and q and tu. So you'll, after an introduction paragraph, we'll go on and explain mu and we'll explain tu, and we'll talk about the law of diminishing marginal utility, which says this, that as q rises, mu falls. As we consume more and more of a quantity of a good, its extra utility falls. And then we'll say this, that it's an important sort of principle because this principle helps us to understand how a consumer maximizes utility. Because, for example, you say this, that if there are two goods, good A and good B, okay, and mu of good A over price of good A is greater than mu over of good B over price of good B, then a consumer basically is getting more satisfaction per dollar spent, maybe like this, more satisfaction per dollar spent from good A than from good B. Isn't that true? Marginal utility per dollar spent is more from good A than from good B. That would mean that he should buy more of good A, so quantity of good A should go up, quantity of B should go down, and as he buys or she buys more of A and less of B, mu of A would rise, mu of B would fall, but this will continue till mu of A over price of A becomes equal to mu of B over price of B. And that's where the consumer is maximizing his utility. Okay. The last part you will have to mention in this question, which is basically that this helps us to understand why demand curve is downward sloping. Because when the price of a good goes down, the marginal utility per dollar spent of that good would go up as compared to another good, and that would make us buy more of that good. And that would explain simply why when the price goes down, we buy more of that good, because it's the marginal utility per dollar spent that goes up, and you are doing this because you want to maximize your utility from your limited budget, and that's why this happens. Okay, so that's your answer for this question. Even in this one, like look at this, explain the theoretical link between utility, price and the demand for a product. Same question, same answer. What's the link between utility, price and demand for a product? Make sense? You talk about mu, tu, equimarginal principle, law of demand. How does, when the price goes down, marginal utility per dollar spent goes up? Exactly the same answer for this question. Okay. Again, another question, same answer. Explain how a consumer allocate expenditure according to the principle of equimarginal. Analyze how a change in income. Change in income, let's just talk about this variation. How a change in income might affect allocation. We know this, that income goes up, then the demand may rise as, or not as, if the good is normal. If the good is normal in nature, then the demand will shift outward. For the same price, we will say that the income has gone up, so you're buying more of that good. Okay, so they're saying analyze how change in income might affect that allocation. So in the end, once you explain your equity marginal principle and downward sloping demand curve, you can say that it's a non-price factor. This is a non-price factor. And if the good is normal, the demand will go up. But if the good is inferior, the demand may go down. So depending on, you can write that here, depending on the nature of the good, the demand may rise. Okay. Let's see another question. Okay. Again, same thing. Use the theory of marginal utility to analyze how consumer will normally buy more of a product at a lower price than at a higher price, and explain how this theory can be used to drive a market demand curve. Just quick note, how do we drive a market demand curve? This is a little extra. We say this, that sum of individual consumers' demand curve is the market demand curve. So the whole of the answer is the same, everything is the same except for this last analysis, that once you talk about the marginal utility, MU, TU, equity marginal principle and all that, and then in the end you could say this, that this can be then used to derive a market demand curve by summing all the individual consumers' demand curve. All the individual consumers' demand curve would be the market demand curve. Got it? Is that fine? Are we good? Okay. Thank you very much, guys.